let's look at what the simplest private cellular Celona LAN deployment would look like. We would call something like this a site, like a single deployment where you have access points. You'll have your cellular devices. You'll have your Celona access point, a Celona edge on site, and all we need is power and some way to the internet, and we're ready to demonstrate or show, right? So in this type of environment, when you have a Celona edge on site, whether it's physical in a one or multiple servers for clustering or redundancy, or whether it's virtual, I'm going to talk about these dots. So when your cellular device attaches, it obviously connects to the Celona access point. The Celona access point has an encrypted tunnel to the edge. And so data coming in and out of your device actually comes in and out of the Celona edge. Now think about how horrible performance would be if I took this edge and moved it to another site or in the cloud. Knowing this, you would have to what we call hairpin to get traffic to come to a local server. Let's say we move this edge all the way out. You still have to have that encrypted tunnel. So think of the Celona AP and edge as like basically one big box in this type of solution, right? So how can we remove some of the friction in these deployments? We want to do that by getting rid of this edge box. So as Puneet mentioned, how you would do this, and not getting too deep in the weeds, like summarizing, you would take the parts that you need to actually handle traffic, some IP addressing, maybe a little bit of routing, move those services into the AP, such that hopefully you have enough horsepower in your AP to access point to run that. And then whatever else doesn't need to be local, move that somewhere else to the cloud, as an example. And that's what I have here on the table. So today I have two devices. I have my Apple iPhone 16 Pro. I have a Zebra TC78 with a built-in barcode scanner. They're both attached to this Celona access point. Celona access point is directly connected to this. I'm combining these two boxes because it's actually one device. It's a cellular router with a public provider SIM in it. I'm going straight to the internet on this setup. Also connected to this cellular router is this laptop from which I'm presenting. This laptop will be running iPerf so that we can do a little bit of throughput today in this demonstration. And then in the cloud, we'll have the portions that we've taken out in the edge and the cloud, as well as the Celona Orchestrator, which is a cloud-based service to manage all of your Celona deployments. So let's look at that. Okay. So when you first log into the Celona Orchestrator, you'll be greeted by the site's kind of a summary information about what's running. I've got edge out in the cloud, access point, and two of my devices. Let's drill into the devices. All right, so I have two active devices, my Apple iPhone and Zebra TC78. The ICC ID identifier for the SIM on the Apple iPhone, I'll start with that. Just remember 8448. We're going to see those numbers again on the device itself. Both of these devices have IP addresses from a 169.254. Someone's serving that somewhere. We'll talk about that in a bit. What I'm going to do now is I'm going to screencast my iPhone, and in screencast it takes over the whole screen. That and there. So this is my phone. Let's go to the web. We can see on the upper right, we are connected to a 5G network. That's Celona. I'm telling you it's Celona, but yes, we're now just seeing full bars, 5G. I'm clicking on the Celona website. That's going. Let's look at 5G LAN overview. Great. All connected. Let's see some attributes on this device. So in settings, you can go to General, You can go to About, and if you scroll to the very bottom of that, you can see what SIMs are installed. Again, this is on the Celona non-public network. It's a standalone 5G network. And again, we see the ICC ID of 8448, proving this device is actually connected on this network. That's pretty much all I wanted to show for iPhone, for Apple. Now I'm going to switch over to another device. Let's stop mirroring that. And let's go to our Zebra. Now, interesting thing about Android-based phones, you get a little bit more information. So I'm going to share this screen. The numbers we want to remember here for the Zebra TC78, 8361, and this, oh, there's that one's easy to remember, 82.82 for an IP address. So let's look at this device. I'm going to do a screen copy of the phone. Stop that. This one I want to pull up. Orchestrator, we'll just bring this down just a little bit so you can see the device. Okay, so let's make sure we're up and running here. Again, on the device itself. We're able to, again, browse the Celona homepage. Look at something, a little bit of information on Orchestrator. Okay, I am connected. Great. Let's look at the attributes. Again, in settings, about phone, we can scroll to the bottom. We can see our IP address of 82.82. So that's the same device. And in terms of the SIMs, scroll up a little bit. You can click on the Celona SIM. And 8361, 8361. Same device. Okay, great. Let's do something a little exciting. So this 169.254.8282 IP address, where does that come from? In the default settings for Celona, Celona issues that IP address. Just like you can purchase a commodity Wi-Fi device, at the store, plug it in at home and get internet connectivity, and get an IP address from that device, which nats you out into the internet, you can do the same thing with a Celona access point now. Plug it in, give it internet access, it comes up, you get an IP address in this 169 range. Now in enterprise networks, perhaps that's not the IP address range you want. Maybe you want your devices to have the same kind of IP addressing that your, for example, IoT devices are running. So let's do that. Back to the Celona Orchestrator. What I'm going to do is I'm going to disable or deactivate the Zebra TC78 SIM for the Zebra, and I'm going to reactivate it with a different device profile. So the default device profile by default gives you an IP address from Celona. But we're going to change this to a different device profile, which instead of getting an IP address from Celona, Celona on your behalf will perform a DHCP request upstream and get an IP address from there, like with the rest of your devices. And just to call out, in cellular, there is no DHCP. There is no DHCP. Like, where do you get these IP addresses from? The provider, it's part of the cellular standard. When the phone connects, there's a session to give the IP addresses. And of course, with a public cellular provider, you're not able to control that addressing at all. You get whatever blocks of addressing the public provider has allocated. With Celona, now you have choices. You can use Celona itself to give you an IP address from Celona itself, or you can forward a DHCP request. We can forward a DHCP request on your behalf, to get an IP address. So let's do that. Let's make sure we authorize it for all sites. Do that. Give that a little bit to propagate. Let's see here, I have bars without 5G while I'm waiting for that configuration to propagate. A little bit of silence while we're waiting. Okay. That was exciting, wasn't it? I was getting a little nervous, but no, it came. Oh, back online. Okay, let's prove it. Let's prove it. Okay, okay, that's working. Industries, oil and gas. Cool, working. Attributes. Back to about phone. We go here. We go to the bottom, and now you see we are getting an IP address, not from Celona, but the enterprise network, 172.123.0.120. Great. Now let's go into what we just mentioned earlier regarding local breakout. So what local breakout means for us is, back in this diagram, that the AP itself doesn't need an encrypted connection to some other entity and hairpin to get traffic back. The access point itself can route traffic directly. So this device, this laptop that we're looking at, that I'm sharing, is running iPerf. This laptop, I'm also doing a direct ping to the internet. So the laptop is directly connected to the router. It's going straight out to, I'm pinging Google here. Okay. So let's do a little bit of throughput. No, not with that, with this. Okay, hit run here. And we are running. Great. So your data now doesn't have to traverse, if you're not using, such that you don't have to use a public network provider, your data stays on your network. Your data doesn't have to go to someone else's network. That's essentially what a public network provider is, right? Public cellular network providers. Your data in someone else's network, routing and IP addressing, you can't control it all. With this now, that all the data stays local. But that's great. So how I want to end this, I want to end this on an exciting note. I'm going to do something really daring here. What I'm going to do is I'm going to log into this cellular router.
Disconnect.
And I'm going to cut off the WAN. I'm going to turn off the cellular network. I'm going to let it drop pings for, say, 3 or 4 pings, and I'm going to come back. So Zoom folks out there in video land, I'm going to disappear for a few seconds, but I will be right back. Starting now. A little bit of nervous tension. Let a few pings drop. Re-enable the modem. Give me a little bit. I should come back. I should come back to the presentation.
Can't see it.
Am I coming back?
Yes.
Sweet. As you can see here, we dropped a bunch of pings from this laptop. But when I scroll over to the iPerf, oh, there was a little blip right there. I'll take it.
Disappointed.
So
those 30 megs were important. Very good.
We should have. There was that was a ooh.
That wasn't.
That was very cool.
Yeah. Yeah, in terms of the local breakout capability, I see that as a competitive differentiator advantage. And I guess
I think I would go beyond that. I would say, as of right now, we're the first anybody in the whole world to present edgeless private cellular 5G LAN.
I hear you. And yeah, I guess, But and also, this is kind of another and observation. How are you presenting this? Like, okay, this could help you with IT budgets. This could help you with cost savings. Those considerations. How's that being positioned?
Yeah, I think going back to what Mehmet was saying earlier, right? If you go back to from a private network perspective, let's keep the neutral host aside for a second. Just from a private network perspective, why are customers deploying a private 5G network, right? And as I said, 100% of the cases today, it's a complementary, it's an and. They're doing that, one, because outdoor deployments, they don't have an option. It's either no connectivity or some connectivity, and now they have the option of deploying a private 5G. Oil and gas refineries, yards, distribution centers, parking lots, you now actually have the ability to deploy a private 5G network and start to digitize your workflows, right? So that's the reason why they're actually deploying. And in that case, it happens to be an and, because typically outdoor will be private 5G, indoor will be Wi-Fi. Now, some of the other use cases that Mehmet was talking about earlier is when you look at manufacturing, right? And you're starting to deploy humanoids, you're starting to deploy AGVs, you realize that you're starting to run into limits of what your current wireless architecture and wireless infrastructure can do for you. And that's why you're looking at alternatives and a more reliable option in terms of private 5G, in which case, again, it becomes more of an and, where you have certain critical applications which need reliability, which need a very, very specific SLA that you need to deliver, and hence you're looking at a private 5G network to actually deliver that.
Very good.
One aspect that can be challenging with the private LT is how you issue those eSIMs.
Yeah.
And I know we haven't talked about it today. We've talked in the past.
Yes.
Could you just describe what you guys do to try to make it as easy as possible for the IT manager?
Absolutely. Thank you. And it seems like the question is planted, because that's, again, a value prop that we are very, very proud of in terms of how we can allow customers to actually deploy devices at scale. Because when I see people deploying private 5G networks and they have to do it with physical SIMs, taking out the nano SIM and putting it in and labeling it manually, it's a very, very manual process. And then if you think about doing that for hundreds of devices, you'll start to see why that would be a challenge. So we invested in eSIM almost 3 years ago. We actually demonstrated that to you guys in the last 2 years. And one of the big reasons, and at that time, the footprint for eSIM devices was very, very low, right? So we invested in that quite early because we knew that was the only way private 5G networks, when they go at scale, that's the only way it's going to be adopted at scale. So one thing was enabling customers the ability to actually use eSIMs. Number two, again, if you have to scan QR codes every single time, that can be a challenge. It's still better than dealing with a physical SIM, but QR codes can be a challenge. So QR code is one way of onboarding eSIMs onto the device. What we realized was customers have MDMs that are using to manage their private devices today. Why can't we use that? Or why can't customers use that to actually deploy eSIMs at scale for all the devices that they actually want to be onboarded onto the private 5G network? So we have actually built APIs that can be integrated into existing MDM systems, where customers can actually push eSIMs at scale to hundreds and thousands of devices. And whenever that device enters the private network for the first time, it'll automatically be able to download the eSIM and then connect to the private 5G network. So we've kind of really made it very, very simple, and we are starting to see customers completely automate the entire workflow of somebody requesting connectivity to private 5G using ServiceNow, going through, getting approved, that profile being added to NAC, like Cisco ICE or Aruba ClearPass, and when the device, and that MDM being used to push the eSIM onto the device, and when the device now connects to the network, everything is now a closed loop because the profile is already defined on your network access control system. The eSIM allows you to connect, and all of this was being done in a zero-touch manner. So we are starting to see customers actually utilize what we had actually built out for them.
That's good. And then do you have any limitation in terms of how many eSIMs you can generate, or it's like on demand?
It's on demand. With every access point, customers do get, they're entitled to a certain number of physical and certain number of eSIMs.
Okay.
And all of those are available to them on demand. And if they want additional, they can always get more with subscription.
Do you have to pay more?
If beyond a certain limit, yes.
Okay.
Yeah.
I have kind of a two-part question.
Yeah.
It's in the same realm. In the US, we have CBRS. All those other countries you had don't have CBRS, but they have something else.
Yes.
So the question is, how difficult have you found finding frequency and getting it and maintaining it and not having to fight over it?
Yeah. good point. And I think, again, when Mehmet presented that global, it couldn't have been just us creating radios with different spectrum, right? It had to happen with countries opening up private spectrum. And that has actually happened at a pretty large scale. And what we are seeing is, not all of them have picked CBRS, but most of them have actually picked frequencies between 3.3 gigahertz to 4.9. And that's, in the cellular world, it'll be band 48, which is CBRS, band 78, band 77, band 79. So there are around 4 bands that are actually being used around the world and being opened up for enterprise use. A lot of them have a CBRS-like model. It's not automated, but you can actually go apply for spectrum, and it is dedicated spectrum that is for that customer, for that particular location. In some countries, you actually have to still work with the operator and procure that spectrum. And we actually have gone out, and I think some of the partnerships were mentioned, we've actually gone and signed those operators up from a partnership perspective so that we can serve our customers as and when a need arises in those countries. So there are a few different models. I don't think there's one size fits all. But the good thing is private spectrum is actually opened up in most of the parts of the world.
And in the US, any issues with, CBRS is a little flexible, as in it's not yours.
You may have it today.
You may have it today, but you're sharing it, and somebody might not be using it, but they have a right to use it, but they're not, and then they do in the future. Just wondering how you're dealing with that flexibility.
Yeah. So, honestly, the US framework is the most automated and scalable framework across the globe, honestly, because we have deployments in Germany, UK, France, Japan, Korea. We have seen it all. And
Canada, right?
And in the US, the model is there's the SAS, obviously, right? Spectrum Access System. And as the AP comes up with the location information, it gets granted for the spectrum. And there's 150 megahertz of spectrum. And you may be in situations where maybe a neighboring building or neighboring refinery may be using CBRS too. So there's some sharing going on. But in the so-called GA8 tier, the General Authorized Access tier, we have a lot of deployments, like in the refineries and so forth. You may have like adjacent refineries using CBRS spectrum, and the SAS system is really helping in terms of how the spectrum is coordinated across these different sites, because each AP needs to register with the SAS. So it's well coordinated, actually, and we have, like in Houston area, in the Louisiana area, we have a lot of refinery deployments next door to each other with the outdoor APs, and they are working 24/7, pretty robustly. So the experience has been really good.
Yeah. And we have built automation in the systems, especially when incumbents want to use their spectrum or PAL actually get activated. There's automation built in the system we get notified by SAS, and we can always move to another channel that is available in the spectrum. So if you have enough automation built out, I think you can still deliver a very reliable network to enterprise customers.
Thank you.